Welcome to lesson 4 of unit 5, Understanding Decay. This begins on page 25 of your student workbook. The success criteria for this lesson are: I can use only multiplication to represent decreasing a quantity by a fraction of itself. I can write an expression or equation to represent a quantity that decays exponentially. I know the meanings of exponential growth and exponential decay. First activity is 4.1, Notice and Wonder, two tables. So what I want you to do now is write down one thing that you notice and one thing that you wonder. Some things you may have noticed is that table A and table B both start with x equals 0 and y equals 2, but where they end up are in different places. You may have noticed that y values in table A differ by 3 over 2, but the y values in table B do not differ by a constant amount. You could have seen that table B has a common factor of 3 halves, so we're multiplying 2 by 3 halves to get to 3, multiplying by 3 halves to get to 9 over 2, and so on and so forth. Some things you may have wondered is there a simple pattern for table B? Will the y values ever be the same after the initial values? And will the y values stay close to each other? All three of these questions we are going to explore in today's lesson. Next, we're going to do 4.2, what's left? This is on page 25. To begin this activity, I want to pose the question, if Diego has $100 and spends 1/4 of it, how much does he have left? Here's one way to think about how much Diego has left after spending 1/4 of his $100. We're going to explain each step here together. So take a minute and look over these steps. Okay, so step 1. This is just the difference between 100 and 1/4 of 100. Step 2, we apply the distributive property and factor out a 100 from our expression. This leaves us with 100 times 1 minus 1/4. Then we replace 1 minus 1/4 with 3/4. Then we just apply the commutative property and flip the two numbers. Okay, so now using this example, I want you to try and answer question 2 and question 3 in your workbook. Okay, let's talk about number 2. A person makes $1,800 per month, but 1/3 of that amount goes to her rent. What two numbers can you multiply to find out how much she has after paying her rent? Okay, so the two numbers we are going to multiply together are the initial amount and the growth factor. Even though these numbers that we're talking about here, the 3/4 up here, and what's going to be 2/3 in this question, are our growth factors. Even though they are less than 1, we still call them the growth factor. So our initial amount is 1,800. And then our growth factor is going to be 2/3. We get that by taking 1 minus 1/3, which that 1/3 goes to the rent. So what's left over is the 2/3. Number 3, write an expression that only uses multiplication, and that is equivalent to x reduced by 1/8 of x. Okay, so again, we're going to multiply our initial amount and our growth factor. So our initial amount in this case is x, and then multiply by our growth factor, which in this case is going to be 7/8. And again, we get that by taking 1 minus the amount that it's reduced by, which is 1/8, and we're left with 7/8. Let's think about this synthesis question. There were X dogs at the park, and 1/5 of those dogs were on a leash. How many dogs were not on a leash? Think of a way to represent your answer. Okay, you may have represented your answer one of these two ways, either the total number of dogs and then subtract 1/5 times the total number of dogs, or you could have done 4/5 times the total number of dogs. Both find your answer. But what we want to think about is that it's important to be able to represent this situation using just multiplication, because exponential situations that we're going to deal with involve quantities changing by a common factor. We want to see that common factor in our representation or our expression. Next, we're going to do activity 4.3, value of a vehicle. This is on page 26 of your student workbook. Every year after a new car is purchased, it loses 1/3 of its value. Let's say that a new car costs $18,000. Before we do the questions in your workbook, without calculating, what do you think the value of the car will be 4 years after it was purchased as a new car? Let's see if you're right. So number 1 says, a buyer worries that a car will be worth nothing in 3 years. Do you agree or disagree? And explain your reasoning. I would disagree. The car will have some value after 3 years. It's not going to be worth completely nothing. But can we find out exactly how much it's worth? All right, let's find exactly how much this car is worth. Use the table in your student workbook to figure out how much the car is worth after 1 year, 2 years, 3 years, 6 years, and T years. I want you to show how you found the values. Okay, don't just write the values in the table. Show me how you found the values. For example, after 1 year, the car is going to be worth $18,000 times our growth rate, which is 2/3. So what would it be for 2, 3, 6, and T years? Go. So for 2 years, it would be our initial value of 18,000 times the growth rate twice, or 2/3 to the second power. For 3 years, it'd be $18,000, our initial value, times the growth rate 3 times, or 2/3 to the third power. After 6 years, it'd be our initial value times our growth rate to the sixth power. So after T years, it'd be our initial value times the growth rate to the T power. So using this information, complete question 3, question 4, and question 5 in your student workbook. Let's talk about it. Number 3, write an equation relating the value of the car in dollars V to the number of years, which is represented by T. That should look like this. V equals 18,000 times 2/3 to the T. What is on the right side of this equation should look the same as what is in the last box of your table. Number 4, use your equation to find V when T is 0. What does this value of V represent in the situation? So there's the work for finding V when T is 0. You substitute in 0 for T and then solve. You end up with V equals 18,000. This is the initial value of the car when it is purchased. Number 5, a different car loses value at a different rate. That value can be represented by the equation D equals 10,000 times 4/5 to the T. Explain what the numbers 10,000 and 4/5 mean in this situation. So 10,000 is going to be our initial value, our initial cost of the car, and then the price decreases by a factor of 4/5 each year. 4/5 is our growth factor. 4.3 synthesis. Let's take a look at these 3 questions. Why does it make sense to multiply an entry in one row by 2/3 to get the entry for the next row? Again, this is because each year only 2/3 of the car value remains, or we're taking 1/3 off of the value each time. Where does a T come in from the expression 18,000 times 2/3 of the T? This is because we are multiplying that growth factor of 2/3 repeatedly, or T times. So we have 2/3 times 2/3 times 2/3 T amount of times. We just represent this as 2/3 to the T power. And does the 4/5 in the last equation mean losing 4/5 of the value each year? Why or why not? No, multiplying by the 4/5 actually means that 4/5 of the value remains each year, so it's losing 1/5 of the value. Keeping 4/5 of the value, which means it's losing 1/5. Lesson synthesis. So take a look at this question. Suppose a digital camera is worth $400, loses 1/3 of its value each year. How can we express the value of the camera in dollars after 1 year or after 2 years? And what is the value of the camera in dollars after T years? Okay, to express the value of the camera after 1 year, it's going to look like 400 times 2/3. 2/3 is our growth rate, 400 is our initial value, and we only multiply it once because T is equal to 1. After 2 years, we have 400 times 2/3 times 2/3. Again, now we're going to 2 years. We multiply the growth value twice. So it's 400 times 2/3 times 2/3. And then we have the value after t years is going to look like 400 times 2/3 to the t power, because we're multiplying 2/3 t amount of times. That is it for lesson 4. Here's the success criteria again. Make sure you complete the cool down and have a great day.